Hello everyone, today I'm very pleased to share our ECCV work, a simple baseline for spoken language to sign language translation. According to the data from World Federation of the Deaf, there are about 70 million deaf people all over the world and more than 200 kinds of sign languages. Research on sign language processing can help bridge the communication gap between the deaf and hearing. There are three major topics in this field. First, sign-to-gloss models can transcribe sign language videos into glosses. And taking a step further, sign-to-spoken models will translate sign videos into spoken language texts. But in this work, we focus on the reverse process that translates text back into sign languages, namely spoken-to-sign translation. Existing spoken-to-sign models may utilize different representations, such as keypoints and 2D video frames. But we observe that keypoints are too sparse to be understood by signers, and video frames may suffer from blurriness and visual distortions. In this work, we propose to utilize 3D avatar to represent sign languages. In this way, the translation results can have more natural motions in the 3D space. To better maintain each sign's original representations, we propose to build our baseline based on dictionary. In contrast with existing works that may utilize external dictionaries, we propose to use a pre-trained recognition model to segment continuous signs into isolated signs to obtain the so-called in-domain dictionary. In this way, the signs in the dictionary align well with the continuous sign language data size. Since existing data sites do not provide any 3D annotations, we build a dedicated 3D sign estimator, Simple Sign X, to convert the previously mentioned sign dictionary into a 3D version. Basically, it's an extended version over vanilla Simplify X by considering three major characteristics of sign languages. First, we enforce unseen joins to approximate the rest poles due to their missing optimization targets. And secondly, to maintain each signer's upright upper body, we enforce the depth consistency for those upper body joins. And finally, since the results will be represented in the video format, we enforce temporal consistency for all joints. The final spoken-to-sign translation can be achieved in a retrieved and connect manner, using glosses as the intermediate representations. Basically, we first translate text into glosses, which are later used as the queries for the 3D sign dictionary. After that, we build a dedicated sign connector to mimic the calculations between adjacent signs. The final outer outputs can be obtained using a renderer software such as Blender. Here are several demos comparing our method with the baseline. It's evident that our method can output much better results. Sometimes the baseline will output very weird poses. And here are several quantitative results. We first adopt the widely adopted metric back translation, and the results show that our method can achieve the highest back translation scores. After that, we also compare our sign estimator with other general 3D sign estimation methods. And finally, we conduct a user study with 4 deaf participants. Their ratings show that our method can significantly outperform the baseline on 3 aspects: the results naturalness, smoothness, and similarity to the ground truth. On this page, we show several qualitative ablation study results of our proposed additional constraints over Simplify X. It's evident that all of the 3 loss terms will contribute to the excellent performance of the whole estimator. Thank you for your listening.